In this video, I would like you to see what I consider the way the pyramids were actually constructed. Contrary to other so-called experts and scientists you see on television or have read about in books. Open your mind and at least consider this idea. Anyway, here we go. I noticed that when they showed the interior of great pyramids, it seemed somewhat hollow inside, like there was a narrow corridor running down the middle. So I wondered if this is the way they lifted the blocks possibly. My sketch image is square like the pyramid outline looking down on it, or a plan view as a draftsman might say. And so is my view of the hollow interior. Picture this. Okay, we know that the initial entrance outside is somewhat distant up on the pyramid, which makes sense because this is the highest they could lift the heavy blocks. After that, they required or used cranes to do the heavy lifting, and it was all done through the center of the pyramid. That is why the so-called corridor is as tall as it is inside. Not only does this allow for the entrance to the interior, it is also the way the blocks were brought in and then positioned and lifted one by one. In other words, they had only to push the blocks to the center of the pyramid on a practically level surface. A second crew would then set the blocks on hoisting pallets. As each level is laid, the cranes are moved one level up at a time. There was no spiral pushing of the stones around the outside perimeter. This would have taken several generations to even consider doing this way. And to even think of a ramp built of sand is also ridiculous. If the Egyptians understood lifting heavy stones, they must have also known about cranes, as did the Romans. With cranes on opposite side of the slot opening or corridor, two cranes on either side could easily lift many large stones every day until they reached the top. Once there, they could have easily used a crane to muscle up the remainder using the exterior of the pyramid with a smooth surface on it on one side. Manual pushing would have been prohibitive. However, a crane pulling from above would have made the lift no different than had they lifted the stone directly upwards. It would not have required many men to operate the crane as opposed to the number of men required to push the stone in the two location. As the pyramid approached completion, they filled in or placed in the roof section of the corridor opening. My concept is the same way people have been building log cabins or a concrete walled room or enclosure for thousands of years. You always leave the entrance open and work from the inside as well as the exterior. When you cannot work outside, you do all your constructing from the inside, building scaffolding using cranes, etc. As the buildings get taller, material is lifted from the outside via elevators as necessary. Even a smooth ramp on one side of the pyramid would suffice using a crane placed on top. Ropes could have easily been draped over the pyramid and pulled from the opposite side using a pulley at the apex. Notice also that the blocks appear to be roughly the same size, just big enough to fit within the corridor. The sandy ramp suggestion is poppycock, as the notion of that huge columns were put in place using lots of sand around them. Once all the columns were erected, they brushed away the sand. The problem with that is that they have no way of knowing how straight they are going up without some reference to the first column laid at the first level. They would have required they build the columns horizontally, much like turning on a lathe. Cut everything in equal size, then reassemble them vertically using sand to build around it. It would have been a lot easier to stand two sections of column, then mount a crane on top of one of them. That crane lifts up the section and places it on top of the other column. The crane gets switched over and does the same for the other one, and so on. When there are 20 or more columns, I can see them being done by several such cranes all working in. Like most cranes today, they come apart, making them easy to transport. The high-rise cranes is a typical design where they keep adding steel frame sections to go higher and higher. The Egyptians did exactly the same thing using the column sections instead. They may not have used a pulley system, however. A cantilever type system would have been possible. So there you go. They're all wrong, the silly scientists. Prove me wrong, anyone. Thank you for watching. Give it a thumbs up if you can. Visit us at larryandjane.com. Thank you.